All right, good morning, guys. So last week we finished our statistics unit and we are moving on to probability. All right, so probability is the likelihood of an event happening and is expressed as a number between 0 and 1. So it says label the terms on the number line. So we have unlikely, equally likely, impossible, certain, and likely. So the definition states that it's the likelihood of an event happening between the numbers 0 and 1. So 0 is going to be impossible. 0 is impossible, then 1 is going to be certain. If you get a probability of 0, that means it's impossible to happen. If you get a probability of 1, that means it is certain to happen. Okay, I went ahead and just crossed off the two that we use. So we're left with unlikely, equally likely, and likely. Okay, well, the word equally likely, that's going to be half, our 1/2 mark, because it's equally likely. It could happen, it could happen. So what we're left with is unlikely and likely. Unlikely is going to go in between impossible and equally likely. So it could happen, but it's unlikely going to happen. So likely is going to here. Likely meaning it's most likely to happen, but you can't be 100% positive. So here are some examples that we're going to go over. Okay, so it says read each example and label the situation with one of the terms above. So one of these terms above. So snowing when it's 40 degrees outside. That would be impossible. Keep doing that. Impossible. I mean, you never know. We live in Ohio, but that would be impossible. 2, burning your dinner if you cook it too long. Well, yeah, that's likely. If you cook your food too long, you're probably going to burn it, but that's not 100% going to happen. So that's going to be likely. Water boiling at 75 degrees. That is impossible. I believe water boils at 212. So this is nothing. 75 degrees is nothing. So that's impossible. Getting a ticket if you're speeding. Well, that's likely. It's not certain because a cop might not see you when you're speeding. So that is something that is likely to happen, but it's not guaranteed. All right, number 5, scoring from a safety in a football game. That is unlikely. It happens, but it doesn't happen often. It's not impossible, and it's not guaranteed. So that's going to be unlikely. And last question for this one, number 6, a coin landing on heads when it's flipped. Okay, well, that's a 50-50 chance. You're either going to get heads or you're either going to get tails. So you have a 50% chance. So that's going to be equally likely. All right, moving on. So simple probability. Simple probability is the ratio of successful outcomes to the total number of outcomes. So simple probability is the ratio of successful outcomes to the total number of outcomes. Sorry about those noises. All right, so example, P A. So that would look like A over the total outcomes. So A is the successful outcomes, so the outcomes over the total outcomes that are possible. That we'll see in an example. So a complement, the probability of the event not occurring is called the complement. The probability of the event and its complement have a sum of 1. So the probability of the event and its complement have a sum of 1. So that would be like, so example, see, this one's a little different. That has P and then a little apostrophe than A because that is showing you that it's a complement. So that would look like not A over total outcomes. All right, question number 7. What is the probability of choosing a marble with stripes? Okay, I'm just going to stop there. So let's look at our marbles. The first marble, they're all very different, but the only one I see with stripes, there's only one, and it's this one right here. Okay, so the probability of choosing a marble with stripes. Well, there's only one chance of getting that, so the numerator is going to be a 1. Well, then it's asking, it has to be over the total outcomes. Well, how many marbles are there? We have 1, 2, 3, 4, 5. So the probability of getting a marble with stripes would be 1 over 5. So the next question is asking, what is the complement of choosing a marble with diamonds? All right, so how many marbles have diamonds? So we see that there are 2 marbles that have diamonds. But it's asking what is the complement of choosing a marble with diamonds. So what of not choosing a marble with diamonds? Well, there's 1, 2, 3 that do not have diamonds. So we're going to put 3, and it's still over the total outcomes. So we know that is 5. So just to kind of reiterate this problem, the first one, it was asking what is the probability of choosing a marble with stripes? There is only one marble that has stripes, so that's where that one comes from. And we have to put it over the total amount, and there are 5 marbles. This one, see the P has a little apostrophe. It wants the complement of the diamonds. There are 2 marbles with diamonds, 3 that are not. So that's why there's a 3 in our numerator. All right, I'm just going to do 2 more problems and I'll wrap this up. So a standard number cube is rolled. What is the probability of rolling a 6? Okay, well, how many 6s are on a cube? There's only one. So it's going to be 1 over 6. So we have 6 as our denominator because a standard cube only has 6 faces, 6 sides. And there's only 1 6, so your chances of rolling a 6 is 1 out of 6. Okay, what is the probability of rolling a 5? Well, it's going to be the same thing. There's only 1 5, so they're going to put 1, and we have to put it over the total outcomes. And it's still going to be 6 because there's still 6 sides. Now it's asking, what are the odds that we are going to roll an odd number? Okay, so a cube has, so we have 1, 2, 3, 4, 5, 6. Those are all the sides of a cube. Okay, well, how many odd numbers do we have? So we have 1, 2, 3. So that's going to be 3. That can be reduced. And we are going to reduce that, which that means we can divide the numerator and the denominator by the same number. Both of these numbers can be divided by 2, so I'm going to divide 2 out of both of those. I'm sorry I said 2, but I meant they could both be divided by 3. So if you divide the top by 3, you get 3 divided by 3, which is 1, and then 6 divided by 3, which is 2. So that is that problem. We're going to do one more. All right, 14. In the movie drawer, there are 7 action movies, 5 comedies and 3 dramas. What is the probability of choosing? We have a drama, anything but comedy, and an action. Well, remember, when we're finding the probability, the bottom number is the total number of outcomes. So we have to find the total number. So we have 7 plus 5 plus 3, which is 15. So we have a total of 15 outcomes. So if you want, you could automatically already put those on the bottom. All right, so we have to find the probability of choosing a drama. Well, we have 3 dramas, so the probability of choosing a drama would be 3 out of 15. All right, 3 over 15 can be reduced if you divide both parts by 3. So 3 divided by 3 is going to give you 1. And then 15 divided by 3 is 5. So your answer for that is now 1 over 5, which now you can't really see. There you go. All right, so anything but a comedy. So we have action, comedy, and drama. So what are the odds that you're going to choose not a comedy? Okay, so we're just going to add 7 and 3. 7 plus 3 is 10. Well, what do you know? You can reduce this. You have 10 over 15. You can reduce both by dividing a 5. So 10 divided by 5 is going to give you 2. And then 15 divided by 5 is going to give you a 3. So that reduces to 2 over 3. And last but not least, what is the probability of choosing an action movie? All right, well, there's 7 action movies. So it is going to be, if I can get it, 7 over 15. And that one we do not have to reduce because we can't. So just ignore that. So that is how you do. All right, well, you cannot reduce 7 over 15, so ignore that. You can't divide them by the same number. So that is that for today. I'm going to leave you a couple of questions as an exit ticket. And if you have any questions, please let me know.